If you thought recent space telescope images were impressive, what you're about to hear may completely reshape how you picture the universe. A new space telescope has quietly begun sending back its first observations, and scientists are already admitting they were not prepared for what they're seeing. These early images are not just beautiful. They reveal a universe that feels larger, more structured, and far more mysterious than we expected. This telescope was never meant to focus on a single nebula or zoom in on one spectacular galaxy. Its mission is far more ambitious. Instead of studying small targets in extreme detail, it is designed to map the universe itself on an enormous scale. Positioned far from Earth, it observes huge sections of the sky in a single shot while still capturing extraordinary detail. That means it can see individual galaxies clearly while also revealing how millions of them connect across vast cosmic distances. What makes this mission so groundbreaking is that it isn't just mapping light. It is mapping the invisible influence of dark matter by studying tiny distortions in the shapes of distant galaxies. These distortions are caused by gravity bending light as it travels through space. By measuring them across millions of galaxies, scientists can reveal the hidden structure shaping the cosmos. When the telescope released its first wide mosaic of the sky, researchers were stunned. In a short observing period, it captured hundreds of images that, when stitched together, revealed millions of stars and galaxies. And this massive dataset represents only a tiny fraction of the full map it will create over the coming years. What we're seeing now is just a preview of something incomprehensibly larger. Scientists can zoom from enormous cosmic structures all the way down to individual galaxies without losing clarity. This ability allows them to see how matter is organized across unimaginable distances. The result is the beginning of the most detailed three-dimensional map of the universe ever attempted. One of the earliest surprises came from observations of a nearby galaxy cluster. The image showed thousands of known galaxies, along with countless faint background galaxies far beyond them. But when researchers looked closer, they found hundreds of previously unknown dwarf galaxies hidden in the cluster. These tiny galaxies are incredibly important because they are highly sensitive to the gravitational pull of dark matter. Their shapes and positions act like tracers, revealing where this invisible mass is concentrated. The discovery of so many hidden dwarf galaxies suggests that dark matter's influence may be far more complex than we previously believed. It hints that the universe may not simply contain dark matter. It may be built around it. The telescope has also revealed unexpected details in nearby galaxies and star clusters. It has detected faint stars that were previously lost in glare, uncovered ancient stellar populations, and even spotted free-floating planets drifting through space without a parent star. These discoveries suggest that the cosmos is far more crowded and dynamic than we imagined. As more data arrived, a striking pattern became impossible to ignore. Galaxies are not scattered randomly through space. They form vast filaments, enormous threads stretching across hundreds of millions of light years. These filaments intersect at dense nodes where galaxy clusters gather, creating a structure often called the cosmic web. Seeing this structure so clearly is both exciting and unsettling. It looks less like a chaotic universe and more like a vast network, with matter flowing along invisible pathways shaped by gravity and dark matter. Everything we see appears to be trapped within this enormous framework. Another powerful feature of the telescope is its ability to measure gravitational lensing with incredible precision. By detecting tiny distortions in distant galaxies, scientists can map where dark matter is hiding. These massive structures do not emit or reflect light, yet they outweigh all visible matter. The telescope is showing us a universe dominated by something we cannot see or directly detect. Its reach into deep time adds another layer of wonder. Some of the galaxies captured in its first images are billions of light-years away, meaning their light began traveling toward us when the universe was young. By observing galaxies at different distances, scientists can watch how cosmic structure evolved over billions of years. Early analysis suggests that large-scale structure may have formed earlier than expected. Galaxies appear to have clustered faster, and dark matter seems to have organized itself sooner than predicted. If confirmed, this could force scientists to rethink how the universe evolved. Perhaps the most humbling realization is how little of the mission is complete. These discoveries come from only a small fraction of the planned survey. Over the next several years, the telescope will continue scanning the sky, filling in gaps and revealing patterns we don't yet know how to look for. At first glance, these images are breathtaking. Galaxies glow, star clusters sparkle, and cosmic structures stretch gracefully across space. But the longer scientists study them, the more profound the implications become. The beauty in these images is not calm or peaceful. It is the signature of a universe governed by relentless physical laws acting across unimaginable distances. The visible universe may be only the surface of a much deeper reality. Galaxies appear to form within vast halos of invisible matter. The structures we see may be guided by forces we still cannot fully explain. Perhaps the most powerful realization of all is this. As the telescope continues its mission, it will reveal